Morning,
I
Pilani. Good
think
day.
we still wait the CFO and the MM inside.
Yes,
You know,
I'm here.
Andy, or
I was just with the acting CFO now. She was walking down to her office. Um,
Petolo.
no, I was saying I unmute, but then I get automatically unmute. I was saying I was just with the acting CFO now. She was walking down to her
Let's
office.
just wait for 5 minutes. Let's wait until 5 past and
Yeah.
everyone is joining. Thanks.
Okay, thanks. Thank you, sir.
Good morning, everyone. It's Duncan Bonnet from the Vice President of the Joburg Chamber. We are just going to wait for a couple of minutes as everybody starts to get into the room. So we will start. I see we've now got 15 and counting people in the room. So we'll just give it another minute or two. It's not going to impact on the timing of the webinar. And we just want to give people a chance to log in. I know that quite often load shedding has the final say as to how easy it is to log in or not, and that's a very topical issue in terms of how you manage your energy. So just give it a couple of minutes. If you can, please turn your microphone and your sound, your sound and your video off. It just improves the quality of the presentations. Thanks. Good morning, folks. We're just waiting one more minute for people to log in, and then we'll get going. Right. Good morning, folks. My name is Duncan Bonnet. I'm the Vice President of the Johannesburg Chamber of Commerce and Industry. And welcome to this webinar on the just energy transition. I think it's an incredibly topical webinar that we're having this morning, not just given the load shedding that we're having, but the cold that's come up from the Cape. We all need a little bit of energy to warm us up. And I'd like to welcome our presenters with us this morning. Before we do that, obviously, you're welcome to post who you are and what your company does in the chat room, so that we all know who's here. You're also, if you have questions or comments as we go through the presentation, please post those in the chat room as well. It's there. That's what it's there for. Please, can I ask everybody to keep your video and audio on mute or switched off, so that it improves the quality of the presentations. And we will have an opportunity at the end of the presentations for a Q&A. So we will be able to do that towards the end of the event. Just to introduce a little bit of background for those of you who are not members of the Johannesburg Chamber. The Chamber was formed in 1890, so it's 133 years old this year, and is a member of the International Chamber of Commerce in Paris, which has been around for about 400 years. And it's the voice of business around the world, championing the global economy, and regulating and ensuring that global commerce takes place at a just and equitable level. The Johannesburg Chamber of Commerce and Industry is also one of the members, the founding members of ASAC here in South Africa, which is the Association of South African Chambers, which is a voluntary organization established in 2019. It comprises 11 of the largest chambers in South Africa. As a measure of the size of the chambers, they account for probably 85 to 90% of all of the certificates of origin that are issued in South Africa, and also plays a key role in advocacy within South Africa. We have played a role in advocacy around things like the energy rates increases, some of the other municipal rates increases that have taken place in the last couple of years, and to collectively lobby and bargain with the government at various levels in South Africa. So through both the JCCI and the ASAC, we provide a very good platform for business to have a voice both domestically and internationally on issues that are of relevance. So please, if you're not members, consider signing up with us and becoming part of our broader family. With that, I would like to introduce Gregory Diana and Kishan Singh from Able Energy, who are going to take us through a presentation on the just energy transition. We're going to be looking at issues like the just energy transition, non-existent company energy management policies and strategies. And I think as we see the price of energy rising as quickly as it has in the last few years, this becomes critical for companies that want to manage their costs in this particular sphere. The process methodologies on energy management, optimizing energy management systems, utility audits, energy audits, and decentralized energy systems. So I would like to hand over to Greg and Kishan to introduce themselves and to introduce Able Energy and to take us through the presentation that they have put together for us. Greg, Kishan, the floor is yours. Thanks very much.
Hi, this is Greg Diana. I think before I proceed, I think Nkosonati should put a few words forward for Able Energy.
Oh, hi, my name is Nkosonati. I'm part of Able Energy. Able Energy is an energy efficiency company that actually specializes on energy efficiency and utilities management strategies. We provide our services to industrial and commercial facilities. within the building space in South Africa, as well as assisting companies to actually try and look at different types of solutions, whether it's alternative energy or energy efficiency in its entirety. So maybe I would just stop there, that brief introduction. Great. Thank you.
Hi, everyone. My name's Gregory Diana. I claim to be an expert of sorts in energy management, energy efficiency, and so on. I was a senior lecturer at UKZN for 24 years. I did energy management. In the last 10 years, I've saved him over 154 million rand. So I think I have some claim to having some experience of energy management and how it works. And I've also been on the Eskom demand-side management program, where we did measurement and verification to approve projects and the like. I think that's all for the moment. Thank you.
Greg, I think you should carry on. I'll introduce myself when we get to my slides. So for now, let's just move along.
All right. Okay, everybody. Once again, welcome. Able Energy's sponsoring this seminar today. As it says there on the slide, I'll be covering the energy management aspects of this just energy transition, and Kishan will pick up on the ISO systems. So as Duncan noted, it's quite a topical thing, this thing called the just energy transition. But a lot of people don't know exactly what just is, or what an energy transition is, and what implications it means, and why do you have to have this whole transition, and so on. And if there are any of you who have put your solar PV on your roofs, as either as an industrial or a residential, if you go to the various fora on Facebook, you will see the many questions that are being asked. Is that, oh, I put batteries on my house and suddenly my bills doubled. Yes, because you've got to charge your batteries and use them. So you find that there's unforeseen circumstances or outcomes for people just doing things because they want to address a need. And engineering goes out the door, and specifications and design goes out the door. And the first thing is to get a need, and you end up with a bigger problem than before, and somebody else to fix that up, and somebody has to pay. So that's where I come in with this. Is it just, or is it unjust? Sorry, I've just got to move my pointer. All right, so in a nutshell, this is a nice slide which sort of encapsulates all the high-level aspects. I'm not going to go into extreme detail because I don't know exactly what all the audience is and how diverse they are. But this whole energy transition is about the whole decarbonization. You know, in South Africa, we have a predominance of coal. In China, they're using more coal than we are, but for somehow we've become the whipping boy for coal. And suddenly it's, well, we have to jump to renewable energy, and that brings with it its own set of problems. The thing is the Eskom power system is not a toy. It's not something which you can just add onto and take off. It has to be managed. It has to be controlled. And if you go to a lot of the fora on Facebook with SunSync and day inverters, you'll see when people put on their standby generators to their inverters, they won't synchronize because the voltage jumps up and down and the system isn't stable under load shedding. So to make all these things work, you have to have some control and regulation over the whole system, because you're adding to an existing system, and of course that's where this energy transition has to take place. Is how do you transition from a system where you had a predominantly single supplier of electricity to this scenario that people are painting where everybody can be their own little generator, and who wants to stay on the grid and who doesn't want to stay on the grid. But we have to realize that in a modern society like today, we live in cities, and cities are metro cities, municipalities are formed on the basis of shared infrastructure. And it's the job of the municipalities and Eskom to get the electricity to our door, which is massive infrastructural cost and which has to be paid for. So going off grid is one thing, maintaining the infrastructure of the city is another. So you can see there's a complex set of relationships between the needs of people to have access to energy, the need to supply that, and the need to maintain it and upgrade it and so on, which is the core of the issues that we are seeing at the moment. Government didn't take that view. Maintenance went down the drain, and we're now sitting with a lot of load shedding and a lot of excuses and confusion. So if you have a look at the slide, there's the decentralization part, which I've just spoken about. Who can do this? You can't just decentralize. You have to become like a little mini Eskom and have rules and so on, so that your appliances and factories still work and supply the equipment. The equipment has utility specifications, voltage, current, and decentralization is not going to take those away. It's just going to have to force people who do that to pay more technical attention to it. So on the deregulation, that's more or less out of our hands. That's more like breaking Eskom up into generation, transmission, and distribution. How's that going to be done? And how are these two going to merge with one another? All right. Then the whole decarbonization aspect is, well, are we going to go solar? Are we going to go wind? Are we going to go carbon? Are we going to go nuclear? So that's a place which is an easy word to use, but it's not so easy to actually implement. South Africa has a very serious problem that Eskom has about 40 gigawatts of power at this point in time, and from 2025, that has to be replaced over 20 years. Where's the new? Where's that going to come from, and where's the new capacity going to come from? So we're in a serious problem. We're dropping by about 5 gigawatts or 1 gigawatt a year. You can see that we're struggling at the moment to bring new capacity online, whether it be nuclear, coal, or renewable, and it's a question of funds. And then the whole digitalization, of course, is you want to digitalize, you want to take all these systems, put them online, be able to see how your system's performing, and so on. So any of you who have a little solar PV at home, you'll see your inverter can connect to the web, your battery can connect to the web, and you can keep a track on it. But a lot of people make remarks, while they have all these pretty graphs, they don't really understand it. So there's this whole energy transition is encapsulating all these aspects that are said, and people are going to have to rev themselves up or bring themselves into the regulatory world. You can't put a solar system in your house. It has to be done by an installation electrician who's certified by the Department of Labor, and they have to sign a certificate of compliance, and the owner eventually takes responsibility, legal responsibility for that. So this is all encapsulated in this whole thing. Whereas before, we just turned the kettle on, we used electricity, we put the stove on, we had a shower, nobody ever worried about this. So it's a new world. If we have a look at this just energy transition, these are the key strategic areas. One of the things that's going to come about, I don't know if you've seen, the governments have got access to large and significant amounts of funding, which doesn't necessarily mean that we have access to that. And to access this financing, there's going to have to be rules in place. So if you want to access this, then make sure that your new renewable energy plant ticks all the boxes so that it can access this finance and that it doesn't impact on the grid and make it worse for other users and yourself. So this financing has a whole lot of requirements, and part of that is your policy and institutions. So you have to have entities which take responsibility for it. So like the Department of Labor takes care of most of the policy around regulations. The Department of Minerals and Energy takes responsibility for new capacity coming onto the grid and so on, new renewable energy, coal, nuclear, and so on. And then there's training and capacity building, which is your universities, your technicons, and so on. And then, of course, the social dialogue and collaboration and awareness raising. Those two go hand in hand, like I'm doing now. It's more about awareness raising and social dialogue and collaboration. So people work by word of mouth. They will end up fighting or arguing. You know, I think Duncan mentioned about rates, electricity. Municipalities have a serious problem at this point in time, is that they're battling to pay their bills, get money in, and cover their staff and expansion of their networks and maintenance. So this awareness raising and social dialogue and collaborations very much key to that. Now, if I just go back here, all this here, as you see, is tied together, what we call the just transition. And this will vary according to who does the presentation and the aspects. So these are just high level aspects. Of course, there's a whole lot of detail. This financing, if you want to get finance through the banks, or the Johannesburg Chamber wants to apply for funding on its behalf through some entity, it's going to have to tick all these boxes around here to do that. And at the end of the day, you can see I'm focusing a lot on financing here, is because in reality, that is the bottom line. And all the others are complementary to that. Now, of course, you have this just energy transition. And of course, as I said, you've got to have boxes in place. All right. And this slide here shows you an integrated management system. This doesn't mean that every homeowner has to go through this process. But if you're a larger company, you're going to have to. And part of, let me just go back. Part of all this policy and institutions and the financing will, in the future, be dependent on having these systems in place. All right. So if you look at an integrated management system, what does it consist of? It consists of a quality management system. So a quality management system is, as it says, it manages the quality of the system, which includes all these others. All right. And then you have an environmental management system. What's the impact of your business on the environment? You have a safety management system, an energy management system, which tells you how to manage energy in your business, food management, information security, and compliance. So there's all these aspects, all right? And some people might just have this. Some people might just have that, or some might have components. And as your business gets more mature and as you move into this transition and try to access funding, you will have to have these aspects all in place. So that's what we talk about, managing that whole transition and finding out what these are, what is necessary, and what the cost is. And this is part here of the entire digitalization process. So it's like going for a bond at your bank, and they want to know the color of your underpants, what your income is, what all these things are, what you've got in place, what insurance, and exactly the same here. So it's basically a whole compliance and quality management system. So this is what I call ticking the boxes. Then, if we look at the first slide, we talked about the very high level. We talked about the various subsystems. And then on a day-to-day basis, this is typically what we're looking at. We have an enterprise, business, we have operations, and then we have what happens in your building or factory or shop floor. So at this level of control, you've got all your transformers, switch gears, printers, paper machines, whatever it is that constitutes your operation that need to be controlled. And then, of course, that all goes into the next level up, which is operations, who monitor all this and make sure that production's produced and quality is assured. So with operations and control, the whole idea of operations is that they show that they control the processes and achieve the required quality and output and production levels. So here you've got feeders, building management systems, water, so on. And here's where you do management and you contain your costs. Our production's down, or the cost of feedstock was too high. How are we going to manage that? And then, of course, at an enterprise level, management wants to have some key performance indicators and also some visualization of how well these are performing and how well operations is managing that. And then, of course, once you've got your products in place and they tick all the boxes, then you can talk about carbon tracking, customer analytics. Once your products in the market, these become far more. Okay, and when we didn't have load shedding and everybody thought that electricity was guaranteed and we didn't have to worry, there was a big focus at an enterprise level. We just sit down and we make money, which is how it should be. But unfortunately, we now with, we got no supply, there's load shedding. What do we do? Do we have to put in generators? What is the cost of a standby generator? Do we put in solar PV? What is the cost of that? And in the end, it has to be a combination of all that. You have standby generators, you have solar PV, and you have inverters to manage the transition between load shedding and operations so that your tooling doesn't break and stuff like that. So this here is clear, all right, in terms of the levels. But the thing is up to now, and this slide most probably makes quite a bit of sense, but the point is how do you achieve that? All right. So there's physical equipment, there's operations which monitors it, and there's enterprise which manages it. But at the end of the day, you're paying for energy. Energy never used to be an issue before. People worried more about the rent of their businesses than the operations. But now with operations bringing intimate supply, it's taken precedence over that. So let's just look, focusing now specifically on an energy management system. So if you look at that diagram up above, all right, if you look at these levels here, I've just encapsulated that in a different system. So here you would have all your equipment at the lower level. You would have your energy management system collecting all the data from the buildings and the equipment. So this is the equipment, these are the buildings in the equipment, and that could be a site. That could be in one part of the country or another part of the factory, and you collect all that information together, and you do basically utility and production management around that. So obviously this equipment requires costs, and of course you want to make sure that the tariffs that you select are the most optimum, and that you try and align your operations, okay, to your costs. So for example, if you're in Ekurhuleni and you're paying 8 Rand a kilowatt hour during peak in winter, that's when you would like your standby generator or PV or battery to operate, because it's cheaper. So you have to understand your operations, you have to understand how your tariff structure works, and you have to put down appropriate solutions to take care of all of those. And then, of course, at the higher level, you've got your reporting performance management. So if you have a look at this slide and you look at the previous slide, you can see there's a direct relationship to them. Then, of course, you've got people down there managing machines, managing equipment, managing production, whatever it is. It doesn't matter whether it's mining, coal, plastics, extruders, all that type of stuff. There's a similar process that you have to do. And these regulations that I showed further up are generic. They're not specific, they're generic. So there's a particular process that every customer or client or industry follows. So we'll move on to that. So at a system level, all right, when you talk about managing all that energy, there's what's the typical energy management cycle. All right. So it starts here where, of course, you design, specify, and install metering devices. So you've got to measure your energy to be able to control it, whether it's embedded in your machine or whether you use external metering to do that. You've got to collect your data. You can't, if you can't measure, you can't control. So you have to have some idea whether it's widgets that you're producing, numbers, and how much energy is associated. That you generally find that if you do metering, it's very reflective of your production. You can just see changes in your energy usage. So it's a very useful tool to have, and many people just ignore this. Then, of course, you need this information to do your process optimization. So you go out and you audit your equipment. You do an energy balance. Is what is coming in or going out and coming in balance? And then, of course, what does each particular process? You have to identify your big energy users. And then, of course, you set a baseline for it. So you say, this is the typical usage of this machine for this particular process, and you optimize around that. So you set a target, and that target might shift. Each year it might go down, sometimes it might go up. And then the next stage, this is your process optimization. And then, of course, you've got your design and development. So in other words, you've you've got this information from your process. What solutions are you going to put? Are we going to put variable speed drives in? Are we going to control this process better? So you have to go through a higher level to come up with solutions to better the process optimization. And of course, you have to manage projects and you have to do intervention tracking. So if you design something, you put it in, you develop a baseline, and then you track it. Is this baseline accurate? Is it being tracked? Is the project that we've developed here on track? And is that solution working? And then, of course, your tracking and monitoring goes back to the enterprise level, where you've got your interactive reporting, performance dashboards, and your energy information system. So if we look at this cycle here, all right, it directly replicates this, but once you get here, you go back to the beginning again. So it's a continuous cycle, and that's quality management in any processes, in a quality processes in any industry. You go through this system level energy management. This here is energy management, but you can replace that with anything that you want to. That's particular to your business. So there are like higher level processes which govern most of the things that we do, from design to implementation to refine to redesign and so on. All right, so if we look at that process, now we're getting down into the detail. All right, and this is a very busy slide, and it's not intended, but it's just to show you. Here are the things that go into that cycle. So if you look at this cycle here, all right, that's replicated in this diagram, and we'll go through each part. All right. So let's have a look. So the first place is collecting your information. So you form an energy database. What does that consist of? It consists of all your real-time energy and usage information. That's your metering and sub-metering, as we discussed in the previous slide. There's your historical usage. That's your municipal billing and sub-billing. Of course, you take all that information and you put it in here. So this contains all your processes and so on, your billing. All right. And of course, what you're going to do is you're going to take this data, you're going to take that data, you're going to compare them to each other, and you'll come up with some inventory reporting. So is the usage on this machine accurate? Is the usage on the business tie up with the billing? And does the energy usage in my billing tie up with the energy usage on my process? And of course, you will look at that, and then you will come here and you'll say, oh, okay, so what is the first thing we do? Let's go and look at our electricity tariff and see how we can take these particular processes and align them to an electricity tariff, which gives us the best bang for our buck. So your operations, your tariff, your energy usage are all tied up with one another, and all that gets put into an energy database. So now you have all this energy. So you now move on to that next stage, all right, which is we benchmark. So we have a particular process, whether it's a paper machine, extruder, plastic, etc. How much energy is that particular process using? Is it optimal? And how can we benchmark it against this tariff or operate it, or is it even possible? So you go and you do your benchmarking, and then you'll go out and you'll do building design, facility, and energy audits. All right, so if it's an office park, of course, there'll be business design, facility, and energy audits. If it's a industrial process, you will go out and do exactly the same process for your factory or whatever it is. And And then on this benchmarking, you move on to, you'll come out, you'll sit down with your operations, you'll sit down with your managers and so on, and say, well, we know what the tariffs are, we know what the benchmarks are, we know what needs to be done, and then you come up with an energy plan. All right. So you're now going to say, well, having taken this data, having analyzed how the business is working, this is what we're going to do. And you come up with two basic plans. One is your demand side. This is what you do inside your factory. And the supply side is what tariff do we do? So these two have to be aligned with one another. Sometimes you just do this once and you don't touch it for the next 20 years. Sometimes you don't. Just depending, tariffs become obsolete. And it's a game between the municipality and yourselves to save energy. So then you move on to, and you come out with specific interventions. One is your operational improvements. One is creating energy awareness, turn the lights off, save the water, do all that type of stuff. And then there's energy saving retrofits. So these operational improvements are something like, you know, let's stop all the water leaks, or let's stop air being lost, or let's stop heat being lost. And of course, that's very much linked to energy awareness, telling people and giving them KPIs to do that. And of course, your energy saving retrofits might be new projects with solar PV and all that type of stuff. And each one of these entails energy and demand savings. These tariffs here, you might be on an energy-based tariff where there's no demand, or you might be on an energy and demand tariff where there will be demand savings. And you can see as I'm going through this, it's actually going through a cycle that we saw previously. And then, of course, what happens is you implement these, and of course, there's demand, energy, and financial savings. That's always the bottom line. There's supply side. These are the supply side savings in the tariffs, and these are the demand side savings that go into here. And of course, you generate some revenue out of that, which you can reinvest into projects. And then all the information from here, you can see from here, all the purple lines, they go into your higher level dashboard. All right. And management, of course, will look at what the bottom line is, what the revenue is. All this information goes back into the energy database. And then you repeat the cycle just as I have. So you'll see here, these white lines are information flow. All right, so all these here are information. The savings are in the green, and the pink are the reporting information. So this is basically the structure that I've developed, and it works very well, and it encapsulates all those processes. Not everything can be put down on a diagram to be cyclical, but you can see in the last 3 slides, they are genuinely cyclical. So if we consider here that your company or your team has come up with an energy plan, you have to go out and implement these. So this is typically that. All right. So you would go out and you do an energy saving action plan. So you would come out, well, we've got a chiller. We're replacing it with a more efficient chiller, or we're going to do LED lighting, or we're going to do this, or rainwater harvesting, and so on and so on and so on. So you will come up with projects, you will identify them, and that typically becomes what is called an action plan. So if you look at this here, this stuff that comes out of here forms your action plan. Right, and then you have a look, what is your action plan? You've got a typical generic project planning cycle: plan, do, check, act, which everybody knows. Not everybody does, but everybody knows. So you've made a commitment, you assess the performance, you set the goals, right? That was done in that slide above. Create an action plan, implement, evaluate, and recognize achievement. So you can see it's definitely sits in here as a cyclical process. In some cases, doesn't work out. You need to go back to the drawing board and start over. But that's all part of this process. And this is generic. It applies to accounts, finance, bookkeeping, anything you want. Then, of course, you've got to take all this stuff here, all right? Yes, this slide up above is busy. This is busy. This is busy. Now what we have to do is to say, well, how do we take all that information and consolidate it? How do we get it out to new funders, the banks, reporting? You might be required by your suppliers to have certain carbon levels, energy usage, and so on. And who's going to believe you? So the question is okay, well, we have to take all that stuff that we've seen in the previous slides, and we have to consolidate it into something that's systematized. And of course, nowadays, it's going to conform to some standard. I think I went through that slide with all the different standards. And here where you will take your inputs, sources of inputs, activities, outputs, and essentially this is a cyclical process within itself. So one example is ISO 9001. So ISO 9001 is all about how you maintain your documents and quality and all that type of stuff. So you've got to take all that information and not just keep it in notebooks or in the technician's locker and so on, as I've seen in many instances. That's got to filter through to higher levels and then be consolidated into a quality management process or system. And that's where Kishan will talk a little bit more about. So you can see in the previous slides here, all that information, all right, it's part of your project planning. It's part of your project planning here, and it's part of this. So you've got a cyclical process which moves through here, all right, and this is systematizing it and making sense out of it and making people accountable for it, KPIs and so on. I think from here is where, Kishore, are you ready to take over?
Yes, Greg, thank you.
Just let me know when you want me to tip a slide.
I'll do that, thank you. You can move to the next slide, Greg. So thank you, Greg, for those slides and for the discussions on those slides. I think that kind of prepares the audience for what I'm about to say. So just to introduce GI Business Solutions, that's basically Global Integrated Business Solutions. We are a partnership structure with Able Energy. So in other words, should anybody opt to take on Able Energy with the view to determining energy savings, in fact, factor savings for your own companies, you might want to then consider some of the possibilities of achieving what is known as ISO 50001. And that's basically what I just want to talk about. So GI Business Solutions is 10 years old. We are 6 people, and we're quite capable of putting in any ISO system, you know, whether it's 50,000 or typically the more common standards, which is ISO 9000, 14,000, 45,000, and a few others. So we have a global footprint. We conduct ourselves across a global market, especially when it comes to training and consulting. We train across various disciplines. That's the ISO systems, but more than that, we do risk management and energy management. And the bigger focus of recent is sustainability, environmental sustainability, which I want to talk about because it dovetails with what Greg has spoken about. But yeah, so that's essentially GI Business Solutions. Greg, you want to just change the slide? So my name is Kishan Singh. I'm the managing director. I have a BSc degree in chemistry, biochemistry, master's degree in quality management and business re-engineering. Busy at the moment with a PhD. This is on the packaging side of the business, remodeling post-consumer metal packaging recovery in South Africa, which I must tell you is in alignment with Section 18 of the National Environment Management Waste Act, which is again talking about waste management in the country. And then, of course, many of you might know this, but Lean Six Sigma is a very, very powerful tool. And I am a black belt through Dr. Mikkel Harry School of Six Sigma. Some of you may know that the entire concept of Lean Six Sigma emerged in the 70s, I think, with Motorola. And the leaders, the pioneers of that was Dr. Mikkel Harry and Bill Smith at the time. So I'm fortunate that I've got my black belt through Dr. Mikkel Harry, and I have his own personal signature as well. Mind you, he's late now. So Greg, the next slide, just press it. Yeah. So just to let you know that GI Business Solutions is certified to ISO 9001 as well. Next slide, Greg. Greg's shown you this slide, and this is just to show you that the typical business today, not only in South Africa, but globally, has a very strong sense of governance. And we have what is known as the quality management system that he's talking about. Now, I've put in the ISO 9001 there on top of that. Then Greg's showing you that there's an environmental management system, which is the ISO 14001. Greg, the next one. So health and safety is also a part of most businesses now. And that's ISO 45001. And then the energy management, which is what Greg is focusing on, is covered by the international standard ISO 50001. Greg. And then if you are in food, which I can see many of you are not in, then there would be FSSC 22001 and BRC, which is the international standards for food safety. And then, of course, I'm not sure if the audience is aware, but currently, not only if you're dealing with Europe and other overseas customers, but even internally in South Africa, the strength or the power of ISO 27000, which is information and security management, is becoming more and more to the fore because all businesses are data driven. So if you're not managing your data, then unfortunately you're not in the running for future business relationships. And so if you take all of these and integrate it together, this is what the typical picture of a proper compliance management system would be. Greg, just moving on. Yeah, so my focus now is going to be on the 50,000. So Greg, I think, has already explained this, so I'm not going to go through it again, but essentially, if you have a proper energy policy, as Greg has very eloquently explained how that would be achieved, and then you have an energy planning, which is you take the demand side of your business and you take the supply side of energy, and you balance that. Now, this is typically what is known as sales and operations planning in a supply chain management process. But this is exactly a supply chain management, but it's managing energy. So you would have that energy demand and energy supply balance, and that will tell you exactly what your gaps are, and therefore what projects are required, and therefore you lead to the implementation and operation of projects. And Greg has shown you, rainwater harvesting, changing your chiller unit to something for greater efficiency. So all of those projects would kind of come out in the wash. And each one of those would then lend itself to RAND value savings and KPIs, which measures the effectiveness of those project control and project management. So all of that I'm speaking about in terms of implementation and operations. Then, of course, you're measuring, you're monitoring, and you're analyzing your effectiveness. So basically, this, and I'm sure many of you can see this already, this is the plan, do, check, and act cycle. So this is the PDCA, the Deming cycle is already reflective here as well. And then the control is where, should you find that you are deviating from your plan, then you bring it back into control. And then, of course, if there are any, no, just go back, Greg, one more. So if there are non-conformities or areas for improvements, then you'd identify those. And then you would conduct your improvement in a, through proper logical root cause analyses, which means that you prevent the recurrences. So I'll tell you what happens, not only in South Africa, but globally. Many businesses tend to firefight. When they find a problem, it's a firefighting issue. We bridge this, we close this gap, we plug this hole and whatever, and only to find that the pressure point is breaking up somewhere else, and somewhere else in the business we have failure. And so we are in a constant firefighting mode. The proper way to do it would be to identify what the problem is and fix it without creating a problem elsewhere in the business. So that is proper root cause analysis, which is all part of the ISO 50001. And then I've got this internal audit of the system because, by the way, this is ENMS, which is Energy Management System, because EMS you may confuse with Environmental Management System. That, of course, is also a very important part of business. But here we're focusing on energy. So internal audit means that we then conduct a proper review and check of all the disciplines that we have written out to see that there is actual compliance within the organization, across the organization. And that then tells us where the failures are. And of course, again, we can use the non-conformity system to identify root cause and fix those up as well. A management review that I've got on the extreme left here is exactly the same. And many of you would be aware of ISO 9001 and many of the other standards that you may be already working on. You already have a management review there. This is nothing new. This would be an integrated management review, which now addresses 50001 as well. So that is 50001 in a nutshell. And if you are able to demonstrate all of this to a third-party certification body, then Greg, the next slide, then you would be certified to ISO 9001. Next slide, Greg. The triple bottom line approach, I'm sure everybody is aware of. Historically, since the Industrial Revolution #1 all the way to current Industrial Revolution 4, that we talk about the fourth Industrial Revolution, we have typically been managing businesses based on the economic or the profitability, the balance sheet. Basically, a company is doing well. How do you know it's doing well? Well, look at its balance sheet, look at its dividend payout, its shareholder returns. I'm looking at this pink circle at the bottom where my cursor is circling. And that, my friends, is where we've been focusing on. However, in the 1990s, John Elkington, it's a name that you should probably take a note of. John Elkington suggested that we measure businesses based on environment. So just as we have a balance sheet for money, can we have a balance sheet for the environment? Can we also have a balance sheet for people? Now, this is where the environment comes in. Greg's talking about only one aspect of the environment, which is energy management. So this actually follows remember, in thermodynamics, we have the first law of thermodynamics, which talks about energy and matter is interconvertible. And I'm saying that if we can run the business, and run the business with profit, but not at the expense of the environment. And this is what Greg and I are talking about. Run the business, but save our planet. We have only one blue planet, my friends. We don't have another one to go to. And if I'll drop this name here, Carl Sagan. Go and watch Carl Sagan's The Pale Blue Dot. It's there on YouTube. Watch it tonight. And you realize how fragile our planet is. And this idea that Greg and I are sharing is this plea, this challenge, this request to let's run our business with a greater sense of environmental sustainability and respect. Not only that, respect for people, because without people, we cannot run the business. If we adopt this, we're adopting what is known as a triple bottom line approach. And here, the sweet spot, which is the center, the overlap of all of these circles, is sustainability. Something that we can do year in and year out, 100 years from now, and our great-great-great-grandchildren will be around because of us leaving that legacy. If we don't do it, I think we leave the planet in a bad space, which is not, I think, our interest. Next slide, Greg. And of course, ISO 50001 will demonstrate your commitment to reducing greenhouse gas emissions, which contribute to climate change, reduce your energy costs, your organizational performance is improved, your reputation is improved, efficiency and productivity, and of course, your clients will be very, very impressed and respectful of you. I think that's about the end, Greg. I'll leave it now to the floor for questions. Duncan, we'll leave it to you and your team. And Greg and I can answer any questions that we can. If we can't, we will come back to you. But thank you for this opportunity. I appreciate it.
Keshan, thanks very much to you and Greg for that presentation. I think it was really very comprehensive and thought-provoking in terms of where we're getting things wrong and what we need to do to understand the processes that we need to follow in order to be more, to manage this process better. Right, I'm going to open it to the floor. If you have any questions, you can either put them in the chat room, or if you would like to unmute yourself to ask a question, please feel free to do that. I would just like to ask that you keep the questions or comments sort of short and to the point, so that we can get through as much as we can. If you'd like, you can also just raise your hand if you'd like to ask a question. Right, I'm just going to go through the chat quickly to see if we...
People feel free to ask questions a little bit out of this, if it's on a practical level or on your operations level or whatever it is. We'll see what we can do. Some people feel a bit intimidated to ask questions, but feel free. I see Mike Tyler's put his hand up.
Right.
Right. Thank you. Thank you for the opportunity. Thank you also for the valuable information shared. My question really revolves around the various energy, or the energy mix in terms of the energy management system. How do we then ensure that we are able to also control, or rather monitor, the consumption from the other mixes, whether it be solar PV, the generator, assuming that your backup kicks in during load shedding, the consumption of diesel, and if you are obviously using wind, to bring that in. So assuming you are running all the mixes in your operations, how do you then optimize your energy management systems to be able to give you the consumption levels of all of these? Did you cover it? Maybe I may have missed it. Are you covering it in the energy monitoring and controlling diagram that you were depicting earlier?
Yes, I think that's a very good question, and a lot of people want the silver spoon answer for it. Look, it depends on basically two things. One is your operations, and the other is your tariffs. All right. So, if, for example, we got a company down here who prints checkbooks and all that type of stuff. For years, excuse me, they've had 2 transformers in place. They can't afford anything to go down. So when I went to them and did energy savings, they said, no, we have to duplicate anything. It's not going to be worthwhile, and everything is duplicated. So there it was, the operational impediment. The energy mix was irrelevant just so long as they got it. So if you're on a flat tariff, an energy-based tariff, all right, generally you've got a fixed charge. In Johannesburg, sometimes the municipalities give you a winter rate and a summer rate, or a high season and a low season. You've got your 3 months, June, July, August, where your tariffs go up because it's winter and the consumption's high for the power stations. And then in summer, it eases off. So you've got 9 months low season and 3 months high season. So in reality, it's a mix between the two, is to say, all right, I was operating off electricity. I've got to have some backup. Solar is only there for a certain time of the day. So you can only optimize or make use of solar during the time that the sun is available. You can't use it at night. All right. But of course, there's rain, there's sunny skies, there's open skies. So you've got to look at your variations. Many industries require a constant supply, and PV can't give you that unless you design, you totally over design. So then you might say, well, okay, but I can use PV, solar PV, to do two things. I can use it to charge batteries, and I can use the batteries at another time when the tariff is cheap or more expensive, or when operations are required. I might use, so there's a combination of the solar, the battery, and then the generator. All right, because there's, if you're running a tooling company and the mains goes, your machine needs a bumperless transfer, otherwise all the tools break. Or you then got to say, well, let's shut everything down because load shedding is happening at 1 o'clock, and then we shut everything down. We switch on our standby generators and plants, or standby plants, and get them running, and then we run everything up again. Or do we want a bumperless transfer? So if your mains goes, it switches over to a UPS for 10 or 20 seconds while the standby generator jumps up or ramps up, and then it goes. And unfortunately, I'm going to say something now which will surprise a lot of people. So you get standby generators, which you can have an automatic transfer switch, some which are make before break, and some are break before make, and they have a big impact. So when your Eskom supply or municipal supply comes back, does that breaker and your PV, for example, synchronize with one another and then open? Or does it open and now you've got to bring a UPS in? So you've got to have a lot of operational experience and design it's not only the energy mix, it's managing how that energy mix is taken on and off. All right. And so you would have to sit down and analyze your production. You would look at your load profile. You would measure your load profile from the mains and see how and when you use energy in your process. You would then have to link those to, all right, if I lose the mains, what needs to stay on and what needs to stay off? And do I have either a generator, PV, or batteries to cater for that? And what happens if the battery goes, and what happens if the generator goes, and what backups do I have? So you can see the things that I'm talking about already talk about some sort of like policy. It's straightforward engineering, but it has to be engineered correctly. All the little technical details, like I said, make or break or make makes a big difference. Otherwise, people just, I need a generator. Let's go down to Builder's Warehouse. I'll buy one, and then they put it on, and it doesn't work properly because they know they need energy, but they don't know how to design a standby generator and what needs to be done. And there's also guys out there who will try and take you for a ride. They'll sell you much more than what they want because they product pushers and they actually got no design experience. So I don't know if this addresses all the issues, Mike, but it's quite straightforward from an engineering point of view, but you have to take all those aspects into account. And if accounted for correctly, you will make the most optimum use of your energy mix.
Yes, thank you so much for that. I just have one more question, if it's okay. it relates to it. My expertise is, or my professional expertise is in the water industry. And
Right.
when we were looking at designing energy management or energy management an efficient energy management system for that institution.
Right.
We looked at various components of operations, from ops to scientific services that has got they do this laboratory analysis, and you've got all of these different aspects, operations reading, doing meter readings and all of that, putting into a database, and then the production itself where ops stats come, operation statistics come in. So, and then we're looking at the various databases that the institution have. Now, when you bring in energy, obviously there's another database that you are adding to the already optimal databases that are there. How do we then use energy management, the energy management, could I call it strategies, to ensure that we are able to optimize the efficiencies in all of these databases? And do you think it would be necessary for a monitoring and evaluation system? I know you covered a little bit of the, when you were unpacking the evaluation somewhere within the presentation. Do you think, the question here is, do you think there would be necessary for a monitoring and evaluation system so that the different energy can go and extract data if we're using AI or BI, whatever? I think the buzzword is now AI, to go and for each focus area or each business area to then extract whatever data, in this particular instance, from an energy perspective, the energy consumption, energy efficiency data that are relevant to that environment. Thanks, I'll stop there.
Mike, you can certainly do that, and it is being done. All right. So I think somewhere in the presentation, Kishan mentioned the ISO 27001, which is a standard for data warehouses and databases and all that sort of stuff. Because obviously, if you want to do what you want to do, that database has to be online, and the data has to be accessible 24/7. Right? If you're integrating it into your operations, Google and Microsoft have AI tools already. There's people who are doing this. But a word of caution: artificial intelligence is exactly what it says. It's artificial. So if you don't have the experience or know how to design your AI is no different to any other control system. Junk in, junk out. If you don't have enough information, it can't make a decision. So if you've got processes which you can certainly program them. I'll give you an example. When I was lecturing at university in the late 80s, 90s, fuzzy logic and artificial neural networks were the rage of the thing. Go into any power station, plant, variable speed drive, and see where you can find a fuzzy logic controller. They still sit down with the old conventional PI controllers and stuff like that. So where those fuzzy logic, artificial intelligence, neural networks start to make sense is when you start handling big amounts of intelligible data. So it's not going to go in and identify a fault or something like that unless you tell it to. All right. So there definitely is a place for that. In the water world, I'll give you my experience. Is I did work for eThekwini. So if you're on a pump station, it's just a pump. And the only thing that can go wrong is an impeller or something gets stuck in the impeller. And it sounds stupid, but many of those lead to burnt out motors because someone put a sack in the water sewage and the impeller got stuck and the motor stalled and the whole thing burnt. and the protection didn't work because people over-designed it, and so on. Then you go to the waste treatment plants, which is even a bigger issue. So, you know, is it a system which just doesn't use pumps, no agitation or anything like that, or is it a plant which uses agitation? The non-agitating plants, they don't use motors. They're already energy efficient, all right? Those that use the agitation, they have problems with impellers, all that type of stuff. So it depends. You've got to monitor. Okay, so you monitor. Then you've got to understand the process. How does the process work? And if certain things are happening in the agitation process, am I able to measure that by measuring the voltages and currents or energy usage of the process? So if that is intelligible and understandable, you can certainly get somebody to take that into an artificial intelligence and replicate what it is that you're doing. So instead of writing a line of code which says, if A greater than B doing this, you can now write it in an intelligible English language. You know, if the reactance level is above this and do that, provided you've defined the reactance level, then you can write it in plain English and the artificial intelligence will make a decision for you. But there's no silver bullet, unfortunately.
Are there any other questions, guys?
There
Thanks.
is one in the chat box. We've got a question. Sorry, I just need to get up to it. Yeah, from Nondumiso Ndodana, who says, thanks for a very informative presentation. Can you please advise on storage? What to look out for when choosing batteries? I see some say lithium batteries, but I'm not sure why.
Okay. All right. So if we go back to the old motor car battery, which is lead acid, all right? Lead acid are not designed to be discharged. If you take your car battery and it goes flat once, that's the end of your battery. You may as well buy a new one. All right. And I think a lot of people who have put inverters using lead acid batteries have experienced them conking out within a few months. So number one, they're very heavy. Number two, you can't boost charge them. They have to charge at a very low rate. Many of you will identify with this. If you've got your alarm system or your gate, motorized gate, and you've got that little battery and it's lead acid, you're replacing it every couple of months. And the reason is not because the battery is incompetent. It's basically that with load shedding, it cannot recharge. You can't take a battery, a lead acid battery, and charge it at the levels of a lithium ion. So what happens is it charges and discharges and discharges, and eventually it goes below 50%, after which the battery basically conks out. With these lithium ion batteries, they've got a much higher energy density. They're about 1/5 the weight. They can be charged at a very high level. So in other words, if you put a lithium ion battery in your car gate like I've done, I haven't had a problem since, because it's able to recharge. It's the slow charging of the lead acid battery that's the problem, not the battery itself. But you should never let a battery, if you can use lead acid and you can sure it'll never go down below 60 or 50%, it'll operate quite happily. But there's people who believe even with a lithium ion that you can put it down to 0, and it can do so many cycles, and then after that it suffers exactly the same fate. So I, for one, will choose lithium batteries, because they've got a higher energy density. They can recharge much quicker, but of course the recharge you're going to have to pay for. So for example, give you an example, let's say you're at home and you've got load shedding, and everybody baths, and you've got your battery on, and the electricity comes back. Well, number one, your geyser turns full on, and number two, so does your battery. It starts to charge. So you end up drawing more current, and the whole thing of load shedding gets beaten because all the people with batteries and baths draw huge amounts of additional load that wasn't there for the past 2 hours. And those are the practical problems that the city of Cape Town, where lots of people are using batteries, and Johannesburg are having now to contend with. So you've got to have a strategy which, for example, will use your battery and then it'll wait until the day, and then the PV can charge the battery and things like that. And that comes about the previous question that was asked by Mike is, how do you optimize these things? How do you control your energy mix to make sure that you don't end up with a bigger problem than you had before? Nondamisa, is that okay?
Yeah, I think that's comprehensive.
Okay. Right. We have another question from Sisa in Jikalana, who'd like to get your thoughts on what's the comparable opportunity cost between waste to energy and other technologies. Please factor in the positive effects on health that waste to energy impacts by removing feedstocks such as waste coal or CO2 in some manufacturing operations. Greg Kishan, I'm not sure if you've got any thoughts on that.
Greg's question.
Yes, hello to Cesar. I've known him from quite some time back. Yeah, look, the whole waste to energy issue is about, having the opportunity. So, for example, a lot of wastewater treatment plants, they put out sediment. And of course, that sediment, once dried out, can be reused, but you have to have an economy of scale. So with a lot of these things in Europe and where there's waste production and stuff like that, they actually produce like business parks, or they make sure that the process is sufficient to make that waste energy sustainable. Because at the end of the day, everything, sustainability is also about financially stable sustainability. So there are many places where overseas where there's a lot of waste to energy being done. It is being done here in South Africa, but not on the large scale, because we tend to build our factories and things very well spaced apart and stuff like that, and you need for all of that to come together. For example, when I was at the University of KwaZulu-Natal, there was a guy down here who collected food waste. So he went to all the restaurants to collect food waste, and he got a couple of tons a day, and he was going to build a power to energy plant. And it turned out that it was cheaper just to take the gas offtake. So if he put that all in a biodigester and took off the gas, the cost for converting the gas to electricity and the transport costs was too expensive. So they ended up not doing that, and they ended up taking all the fertilizer and taking it to a lot of garden shops and whatever, and sold it as fertilizer. So there's an ideal opportunity, economy of scale, the cost of going from gas to electricity. There wasn't enough feedstock to support that. So a lot of these waste to energy depends on your feedstock. If you've got enough feedstock and that's a sustainable supply, it will definitely work, but it has to be planned. So the thing about impacts by removing feedstock such as waste coal or CO2, certainly if you've got the feedstock, it can replace. So if somebody's using coal and they can go on to wood chips, there's been a wood chip factory here in KwaZulu-Natal which shut down, basically because they didn't have the quality of the wood, and they couldn't keep up with the quantity of feedstock required. But what CISA is saying is if you've got sufficient feedstock and so on, there's absolutely no difference. And then, of course, the big thing is what is the cost to implement, as opposed to, you know, if you've got coal and you're putting waste to energy, is there going to be any bang for its buck? But a note on that, Nkosinathi and I have noticed in the industry that there's, and especially in municipalities, there's like in the Durban Chamber, there's a sustainability group and there's an energy management group. So one in the sustainability energy group is DeFi, and for their brand, they just implement solar because it's good for the brand. The guys on the energy management side want to count every penny and what's the bang on the buck and all this type of stuff. So it depends on the focus of the organization. Some implement renewable energy solutions because it's good for the brand and money isn't an issue and costs. It's about the brand and what they're selling out there. Other people and smaller companies, it's a cost and it has to have a payback, otherwise it's not going to be implemented. So there's these two different schools of thought in the way they implement renewable energy solutions. Quite interesting.
Great, Greg, thanks so much for that. I think we are coming towards the end of our time. There's sort of 2 minutes left, so I think we've managed the time very well, and it's been a really interesting morning, and I hope everybody gained a lot of insight into the question of energy management and how you need to go about it. Greg and Kishan, thanks so much for your insights. And I hope that, you know, you obviously have their contact details that you're able to, perhaps if you have questions that you want to ask off this chat, certainly get hold of either Greg or Kishan and take up the conversation offline with them. So I would just like to in closing, say thank you again to Greg and Kishan for your presentation, for your insights and your very valuable advice that you've given to some of the participants who've been here this morning. Thank you, obviously, to everybody who attended this morning. I see a couple of people have dropped off, but for those of you who are still with us, thank you very much for being here. As you know, this has been recorded, and I'm sure that the Chamber will be sending a link of the recording to everybody who has been here this morning. So just from my side, thank you very much, and we look forward to seeing you at the next event. If you just log on to the Joburg Chamber website, you'll be able to see the list of all the upcoming events that we have and that you are invited to participate in. So from my side, thank you very much, and have a great day further. Thank you. Cheers. Bye-bye.
Thank you.
Okay. Bye-bye to everybody.
Thank
Have a
you.
good day.
Bye-bye.
Bye.
Thank you. Bye-bye. Bye.